right, so the discriminant is this handy little formula. Capital D equals B squared minus 4AC. So the little a, the little b, and the little c are the same a, b, and c that you've been using all along in the standard form of a quadratic equation, okay? And we're going to see this b squared minus 4ac come back later in the note sheet. You might even recognize it if you have some familiarity with the quadratic formula. But this little piece itself is called the discriminant. And basically what the discriminant does is it gives you a way of telling what the solutions will be like. It doesn't tell you what the solutions will be. It just tells you what they'll be like, okay? So this number is like a score, and the score can fall into three categories. This score can be less than 0, it can be equal to 0, or it can be greater than 0. And depending on which of those three categories the score falls into, it tells you about the nature of the solutions. So if it's greater than 0, then that tells us that there will be two real solutions. They could be any kind of like nice numbers, positive numbers, negative numbers, ugly numbers, doesn't matter. We're just guaranteed that there will be two real solutions that are different from each other, okay? If this discriminant turns out to be exactly equal to 0, then it turns out that there is one real solution. But I'm going to put one in quotes because it's actually two solutions that just happen to be the same as each other. Yeah, so it's like when I have, well, a perfect square is actually a slightly different thing, but it's like when you have a perfect square trinomial, like we were talking about the other day, right? Like if I have x plus 3 in parentheses squared, if I had that as the trinomial, I would factor it. I'd be like, oh, the solution is -3, but that -3 is coming from two factors. They just happen to be identical to each other. Does that make sense to everybody? Yes, no? Yeah, because we've looked at this a little bit. And then the other scenario is bringing in our new topic, which is imaginary numbers. If the discriminant is less than 0, then we're going to say two things. We're going to say that there are 0 real solutions, and there are 2 imaginary solutions. And imaginary is not like what my 7-year-old thinks, right? When I'm sitting at the dinner table and my daughter's like, I'm not going to eat unless daddy tells me a princess story. And my husband has to make up a story about princesses going on adventures. And it has to be a choose your own adventure story where it's like, okay, are they going on a train ride or a hike in the woods, or are they going on a boat trip? And we have to like stop like every few sentences and have a little choose your own adventure, or my children don't eat. It's a bad habit that we've developed at our house. It's a little bit rough. So not that kind of imaginary, okay? Not things that we make up, things that don't actually exist. Imaginary solutions actually exist. And some unfortunate person who works in a college somewhere probably came up with this terminology of imaginary as being the opposite of real. And every high school math teacher since then is like, oh, you don't work with teenagers, because what's your natural reaction? If it's imaginary, why do I need to learn about it? Right? That's what everybody feels. Well, they're not that kind of imaginary, and you do need to learn about them. So we'll get to it later. All right, so let's do some problems. So first of all, with the discriminant, it gives us the ability to tell what the nature of the solutions will be without actually having to calculate what they are. Because sometimes we don't care what the answers actually are, we just care what the nature of them is. And I'll give you a real-life example of that in a minute, but first let's just do some arithmetic. It says, what is the number of real solutions of -x squared plus 14x equals 49? And like every problem except for completing the square problems, we have to have 0 on one side before we can actually apply the discriminant. So the first thing we're going to do is rewrite it as -x squared plus 14x minus 49 equals 0. Because then we can say that a equals how much? -1, and b equals 14, and c equals -49. And we'll evaluate the discriminant. We'll say capital D equals 14 squared minus 4 times -1 times -49. All right, somebody with a calculator, tell us what that is. All right, so that all comes out to 0, which tells us what about the solutions? There is one real solution. So we know there is, let's say, one unique real solution. For right now, if you looked your answer up in the back of your book for a similar problem, your book would just say one real solution. But I know what's coming in Unit 5, and I know that if we could start developing this idea of one unique solution as being different than actually only one solution, it's going to help you for later on, okay? So we're going to say one unique real solution, which means there are two factors that generate the same solution. Everybody good? Yes, we're okay? All right, so here's the next problem that we're going to do related to the discriminant. It says, rocket is launched from the ground with an initial vertical velocity of 150 feet per second. The function h equals negative 16t squared plus 150t models the height in feet of the rocket at a time t in seconds. Will the rocket reach a height of 300 feet? Explain your answer. Notice, it doesn't say when will. It just says, will it happen? When the question isn't when, it's just if, all we need is the discriminant, because we don't care when it happens, we just care whether or not it does. Does that make sense to everybody, right? So I don't want to do any more work than I have to. Those of you who have seen the quadratic formula before, you know it's long. You don't want to have to do that whole thing if you don't need to. The discriminant is much less, but we do have to think about this for a minute. We're reaching a height of 300 feet. Where does that 300 go? In for the height, right? We're saying, does this ever happen? Negative 300 equal to, 300 equal to negative 16t squared plus 150t. And we know from the last problem that we can't apply the discriminant until zero's on one side. So we're going to subtract that 300. So we're going to have 0 equals negative 16t squared plus 150t minus 300. We want to know, does this have any real solutions, right? Because a rocket isn't going to reach that height in imaginary numbers, right? It's going to reach that height in real time, or it's not, okay? So we're looking to see if there are real solutions. So we're going to do our discriminant. We're going to say the discriminant equals, no set notation, what am I doing? B squared, so 150 squared, minus 4 times negative 16 times negative 300. So again, people with a calculator, grab your calculator, do that arithmetic, and tell me what we get. Okay, what is it exactly?
Like it's whatever 256 minus 4800 is.
We have a disagreement? All right, Laura, what did you get? 3,300. So what's 150 squared? 2250? Or no? 22,500? And this is negative, 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 so it's going to be minus. What's 4 times 16 times 300? 19,200. So yeah, that's going to come out positive. Is everybody okay with that? Yeah? So this comes out to be a positive number. So we would say, yes, it will happen. We don't know when because they didn't ask us that. Okay? So here's an example. So my husband, when I first met him, worked for Dean Kamen at Deca Research and Development. He worked on a water purification project. Like if you've ever been to the Sea Science Center in Manchester, there's this like thing it's a sample of the water purification unit that Dean Kamen's company developed. That was my husband's project when he worked at Deca long ago. So anyway, one of the other projects going on at Deca when my husband worked there was a military application, and they basically wanted to know if they could do something, okay? So when they're doing the math to figure it out, it involved launching things in the air, being vague. So it involved launching things in the air. So what did they need to know? They need to know at first, is it going to work, right? Later they could fine-tune the details. Engineers are all about doing as little math as they actually can. So you have to learn a whole bunch of math to be an engineer, but then once you are an engineer, your goal is generally to do as little actual math as you have to at any given moment. You only do the math when it's like absolutely necessary. So they would want to minimize their math. So they're going to want to dial in approximately how it's going to work, mostly off of gut instinct. And then they're going to test the math a little bit before they start actually going into the lab and doing testing. So they had to figure out, like, if I want to launch this thing. So they would have started out with the minimum math. After they dialed it in based on gut instinct, they would probably do some discriminants to figure out if it could happen, to try to get like a range of values to go out and test. Does that make sense? All right. In the years when I'm not recording, I give a little more information than that. But I'm going to record and put this online, and I don't want to get myself in trouble. So we'll stop there. All right. So this is when you just want to know, does something happen, not when or how. Okay? All right. The quadratic formula is when you want to know the when and the how. Now I'm going to write the quadratic formula two ways. I've already shown you the discriminant. So the short version of the quadratic formula is x equals the opposite of b plus or minus the square root of the discriminant divided by 2a. Okay, that's the short version. The long version that most people memorize is x equals negative b plus or minus the square root of b squared minus 4ac, because that's the discriminant, divided by 2a. And I promised you I would prove that to you. I will eventually, just not today. Okay?
That looks suspiciously like the vertex form.
Yes, the vertex form is absolutely related to that, and we'll talk about that too. Okay? All right, so that's the quadratic formula. There are very few things that I just straight up need you to memorize. The quadratic formula is one of them. It's kind of like if you come out of geometry and you haven't learned that the Pythagorean theorem is a squared plus b squared equals c squared, you'll probably missed something major, right? If you come out of algebra 2 and you can't spout the quadratic formula, you missed something major. Everybody good? Yeah, it's one of those things. Okay. So now this is used when we actually want to know the solution to something, okay? Not just what type of solution or whether or not the solution exists, but what the solution actually is. So we're asked, what are the solutions? Use the quadratic formula, and we have this quadratic equation. So step 1, the equation has got to be set equal to 0. We can't solve it, okay? Only solving by completing the square, we don't have 0 on one side. So we're going to have 5x squared minus 2x minus 2 equals 0. And we're going to do the quadratic formula. And you guys are not going to develop a very common bad habit. Okay? So look at the quadratic formula. What does it say first?
Minus b.
No. What does it say first?
Minus d.
It says x equals. Thank you, Maggie. It starts with x equals. Do not develop the bad habit of not saying that. Okay, here's why. People who develop the habit of not saying that forget what it is that they're actually finding. And then when I start asking you to solve word problems, you don't know how to interpret the math that you've done. Does that make sense? So you always need to use this variable. We are finding the value of x that makes y equal to 0. Okay, so we have to say x equals. So x equals. What's the opposite of b in this case? 2. Plus or minus the square root of the discriminant. So some people like to calculate the discriminant first and then just write it here. Other people just like to write out all the long math. I'm going to show you how it makes it a little bit less tedious if you calculate the discriminant first. So let's take a minute and calculate the discriminant on the side. Remember, the discriminant is b squared minus 4ac. So what's b squared in this case? Nice and loud? 4. Minus 4 times a times c. So 4 times 5, whoops, minus 4 times 5 times negative 2. Excuse me. So this is 4 minus what? Oh, no, wait, plus what? Plus 40, which is 44. So now I can just go over here and put that 44 in. Divided by 2 times a. What's 2 times a in this case? 10. Okay. Now, I am not going to cross out that 2 and that 10 right now. Because even though I absolutely do want you to simplify the fraction, you can't yet. Because there are 3 elements in that fraction. And you can only simplify if you can simplify all 3 elements. And right now, the second element is trapped under a radical. So until you simplify that radical, you can't touch it. So let's think about that radical and the simplifying radicals that you learned in geometry. This is how much? 2 root 11. Is everybody with me there? Right? That was 4 times 11. 4 has a square root. So this is really 2 plus or minus 2 root 11 all over 10. Now I can reduce the fraction. because 2 divided by 2 is 1, 2 divided by 2 is 1, 10 divided by 2 is 5. I can only reduce the fraction if I can reduce it in all of the places. So x is equal to these two numbers, right? One of the numbers is 1 plus root 11 over 5. The other number is 1 minus root 11 over 5. Now, I am perfectly happy with you leaving your answer in this compact format. But if you tend not to remember that that's two answers, then it might be a good idea for you to be in the habit of writing the two answers. And you also need to know that the way your book is going to write it is 1 plus, actually, I think it's going to write it as 1/5 plus root 11 over 5, and then 1/5 minus, come on, computer, root 11 over 5. So your book's going to write it out that way. I don't feel like that level of tedium is necessary on every problem that you do, but you should be aware that that's how the book's probably going to do it. Everybody okay? All right. And like if you were taking the SATs and it was multiple choice, it would be important that you recognize that as being the same as what we've written. Okay? All right.